All right, we're going through our solutions to the Coulomb's law practice sheet. So, first question, describe the relationship that determines the force of electricity between two objects. That is Coulomb's law. So the electric force between two objects is K times Q over the distance separating them squared. Q, that stands for the size of a charge. So the force depends on the size of charges, and then R, the distance separating charges. So these are the factors that the electric force between two objects depends on. So we're going to play around with that proportionality a little bit here with question 2. Two objects each of charge Q are placed a distance of d apart, and the force between them has magnitude Fe. Determine the new electric force when. So Fe is equal to K Q1, Q2. We'll just do that so that they look different, divided by d squared. And so what we want to look at is how that electric force changes every single time we make one of these changes. So if I want to find the charge, the new force when the charge on one of the objects is doubled, so that electric force now is going to be K times 2Q times Q over d squared. So I've got 2KQQ over d squared. And that is my original force right there. So what I have is twice the original force. If I double one of the charges, I double the total electric force. So then if we go down to the next one, if I double the charge on both objects, that force is equal to K times 2Q times 2Q over d squared. So that gives me 4KQQ over d squared. And again, this is this. It's just my original electric force. So now I have 4 times the electric force that I had before. So I've doubled both objects. If I double the distance between them, so force is equal to KQQ over 2d squared, and we're squaring that whole thing. So this gives me KQQ over 4d squared, which is 1/4 times KQQ over d squared. And again, this is just my original electric force, so it's 1/4 of the original electric force acting on the object. When we make changes to the distance, we're going to have to square those changes, right? So we doubled the distance, we got 1/4 of the force. So now I'm going to double the distance between them, and I'm going to double the charge on both objects. So when I do that, force is equal to K times 2Q times 2Q over 2D whole thing squared, and that gives me 4KQQ over 4d squared. Those 4's go away, and I just get KQQ over d squared, where that's the same thing as my original electric force. So when I do all of that, I don't end up changing the electric force at all. It stays the same size that it was before. So now I have two charges. Here are their sizes. 4 times 10 to the negative 6, 8 times 10 to the negative 6, separated by half a meter, and I want to know the force between them and if it's attractive or repulsive. So to get the force, that's going to be KQ1 times Q2 over the distance separating them squared. So K is 9 times 10 to the 9th Newton meters squared per Coulomb squared times Q1, 4 times 10 to the negative 6 coulombs times Q2, 8 times 10 to the negative 6 coulombs, divided by the distance separating those charges, 0.5 meters, whole thing squared. So if I want to get that value, I need to calculate it, and so we'll go through that calculation with you. just to make sure that we're putting it in our calculators the right way. So we're going to do K, 9, and we do second, comma, 9, times 4 second, comma, negative 6, times 8 second, comma, negative 6, divided by 0.5, and then the 0.5 has to be squared. So when we do that, the force comes out to be 1.152 newtons. So that force comes out to be 1.152 newtons. That's our electric force. And that electric force is going to be repulsive because we have both positive charges. And like charges repel. Okay. Two charges are positioned 1 meter apart. Charge A has a charge of +4. Charge B is attracted to charge A with a force of 12 newtons. Is charge B positive or negative? Well, since they're attracted, we know that opposite charges attract. Because of that, charge B must be negative. So charge B, sorry about that, must be negative. So to find the magnitude of charge B, what we're going to do is say force is equal to K QA times QB over the distance between them squared. So we want to solve for QB. Again, it's going to be easier to do this before you put your numbers in. So we'll multiply both sides by r squared because we want QB by itself. We'll divide both sides by K, gets rid of that, and we'll divide both sides by QA. Those go away. And so what we get from all of that is that QA is equal to this stuff over here. F times r squared divided by K QA. Sorry, we're solving for QB. And so we want to use the numbers that we have. 12 newtons times the distance separating them, 1 meter, squared divided by 9 times 10 to the 9th, that's K, times QA, 4 times 10 to the negative 6th. And if we want to find out what that's equal to, we put it all in. So 12 times 1 squared divided by, and then since we've got those two things down there, 9 times 10 to the 9th times 4 times 10 to the negative 6. And it ends up being 3.33 times 10 to the negative 4th coulombs. So QB is 3.33 times 10 to the negative 4th coulombs. So we had to do a little math in order to get. All right, number 5, I have two charges, an electron and a proton, and I want to determine the force on the proton. So electric force is K times Q for the electron times Q for the proton divided by the distance separating them squared. So K is 9 times 10 to the 9th. The force on an electron is negative 1.6 times 10 to the negative 19th coulombs. The force on a proton is positive 1.6 times 10 to the negative 19th coulombs. And we're going to divide that by the distances that they are separated by, 5 times 10 to the negative 6th meters squared. So that electric force, when we put it all into the calculator, let's see if we can scoot this over so we can see everything. We're going to have 9 second comma E9 times negative 1.6 second E negative 19. Oh, sorry, that wasn't second E, that was second answer. second E times 10 to the negative 19th times positive 1.6 times 10 to the negative 19th divided by our radius, and we can just do 5 second E negative 6 and then square that whole thing on the bottom. So when we do that, it comes out to negative 9.21 times 10 to the 20th. Oh, I made a mistake. Yes, I did. So this is good. When you make a mistake and you do it all at once, you can do second enter, hit the whole entry again, and you have to go back through and find out what your mistake was. My mistake was that I didn't put a negative sign in there. So instead of having to typing the whole thing in again, all I had to do was pull up the last thing I entered. That gives me negative 9.216 times 10 to the negative 18th newtons. So negative 9.216 times 10 to the negative 18th newtons. That's our electric force, and that negative sign means it's attractive. That proton is attracted to that electron. All right. 2 8 times 10 to the negative 6th charges repel each other with an electric force of 100 newtons. How far apart are the two charges? All right, so here we're going to use the same formula that we have for electric force. The electric force is K Q1 Q2 over R squared. So what I want to find is R squared. It's on the bottom. I need to get it to the top. So I'm going to multiply both sides of this equation by R squared. Moves it to the top. I'm going to divide both sides by the electric force. And from that, I see that the radius is going to be the square root of KQQ over F. So we'll put our numbers in. 9 times 10 to the 9th times 8 times 10 to the negative 6, and there's two of them, times 8 times 10 to the negative 6th, divided by the force, which is 100 newtons. So we're going to put that all into the calculator. Clear that out. So we're going to square root, then we're going to go 9 times 10 to the 9th times 8 times 10 to the negative 6th times 8 times 10 to the negative 6th. That's the top part, and then we're going to divide that by 100. I made another mistake. That needs to be a negative sign. And there we go. 0.075 meters. Just wanted to see how to put that into the calculator. All right, number 7, another calculation, but this time there's not a lot of numbers. Oh, maybe we do. Two charges are separated by a distance d and feel attractive force of 2,000 newtons. The distance is doubled to 2d. Find the new force. Well, I know in general force is KQQ over, and we'll say d squared this time. So for my new force, I'm going to have that force is equal to KQQ over 2d quantity squared. And so I get KQQ over 4d squared. Well, that's 1/4 of my original force. My original force was 2,000 newtons, so that's 1/4 of the force. So my new force is going to be 1/4 of my old force of 2,000 newtons. So that's going to come out to be 500 newtons. Number 8, 3 charges are arranged on the corner of a square as shown. I want to know the charge on mass 2. So charge 1 is positive. Two times 10 to the negative 6 coulombs. Charge 1 repels charge 2. So if they repel, like charges repel. Charge 2 is positive, with the force measured to be 7.2 newtons. Okay, so the charge 2 is positive. Now I need to calculate how big it is. So that electric force is KQ1, Q2 over the distance separating them squared. So if I want to solve for one of the charges, I multiply both things by the distance squared, divide by K, divide by Q1, and I'm left with Q2. So this tells me that Q2 is equal to d squared times the electric force divided by K Q1. And so for our numbers, that's going to be 0.1 meters long, but it's 0.1 squared times the force of 7.2 newtons divided by K, 9 times 10 to the 9th, and then also divided by Q1, 2 times 10 to the negative 6th coulombs. So we can put that all into our calculator. We get 0.1, I'll clear that out, 0.1 squared times 7.2 divided by, we'll close parentheses because there's two things down there, 9 times 10 to the 9th times 2 second e negative 6, 2 times 10 to the negative 6th. We put that all in and we get 4 times 10 to the negative 6 coulombs is charge 2. So charge 2 is 4 times 10 to the negative 6 coulombs. Charge 3 is identical to charge 1. Charge 1 was positive, so charge 3 is going to be positive. And so because of that, because of charge 1, charge 3 experiences a repulsive force down. And because of charge 2, we'll call it red, charge 3 experiences a repulsive force over. So the net force on charge 1 is to the bottom right corner of the page. There you go. So we want to determine the electric force on our proton and indicate its direction. So the direction, because they're both positive, that direction is going to be away. They are repelled by each other. So if I want to find the size of that force is K Q1, Q2 over the distance separating them squared. So 9 times 10 to the 9th times 1 Coulomb, that's the 1 Coulomb charge, times 1.6 times 10 to the negative 19th coulombs, that's the electron charge, divided by the distance separating them, 0.01 meters quantity squared. And again, we're going to show you how to do that on the calculator. So we have 9 times 10 to the 9th times 1 times 1.6 times 10 to the negative 19th divided by 0.01 meters squared. Gives me 1.44 times 10 to the negative 5th newtons. All right, determine the acceleration of the proton. Well, I know for the proton that net force is mass times acceleration. So if I want the acceleration, I'm going to divide both sides by the mass. So that acceleration is the force on the proton divided by the mass of the proton. Well, we found the force, 1.44 times 10 to the negative 4th newtons, and we're going to divide that by the mass of 1.67 times 10 to the negative 27th kilograms. So yeah, we're definitely doing that on the calculator, but we have 1.44 times 10 to the negative 5th, sorry about that, I took it wrong, times 10 to the negative 5th divided by 1.67 times 10 to the negative 27th. That gives me some phenomenally huge number. Yeah, 8.6 times 10 to the 21st. 8.6 times 10 to the 21st meters per second squared. That's a lot of meters per second squared.